Hello friends, welcome to my channel. My name is Harshal. So I hope you will be fine. So let's start our next chapter, that is magnetic effect of electric current. So this is very easy and important chapter of the physics class 10 CBSE. So let's start. Come with me. Started. Let's start magnetic effect of electric current. So first of all, power your mind and think about the magnet. What is magnet? What you think in your mind? If you think, then you will obviously you will think magnet is it is a attractive thing. So let's discuss about it. So first about discuss with the example of gravitation. So this is our earth. So this is our earth, we know that, and earth have its gravitational force, gravitational attraction. So a man, a astronaut, it is nearby earth, and a B astronaut, it is the far by earth. So the earth gravitation attract which astronaut? Astronaut A or astronaut B? And the gravitation force is here. So of coursely you know that. So in the gravitation field, the gravitation field, who comes, which thing comes, that the earth attracts it. So the earth attract the astronaut A, and astronaut B is the outside of that earth's gravitation. So by this example we can know that nearby the force is attracted and far by the force is didn't. So let's discuss about the magnet. Here it is the magnet. So it is the magnet, and magnet attract the ion A. It is the ion pieces, ion A and ion B. So magnet attracts, of coursely it attracts ion A, and ion B is not comes in this. So in gravitation there is a gravitation field, same to same. Here the magnet have its magnetic field. I hope you will be understand. So the magnetic field, in magnetic field only ion A is come and ion B didn't. So let's start with the magnetic field. I hope this is the magnetic field. So in magnetic field all are attracted by, means for example the metals are attracted by a magnet. So let's see again. Like this it is look like this, means in a paper there is a magnet and all iron powder, means iron fillings are spread here. So what after that, after we tip means after we change the direction, after we change it or after we move it, it continues like a magnetic field. Means here in edges there is a lot of ion fillings are attracted, here also in south pole and in north pole also, and in middle there is some are attracted. So this is called our magnetic field, where the all ion fillings are attracted by the magnet, bar magnet. This is called our magnetic field. It look like this. We can imagine by imaginary lines. So by this our chapter is discussed, and this is our most important basics. So let's move ahead. Yes, you can see here it is the magnetic field have been created, and here is the magnetic field lines. By this you can imagine it. I hope you will be understand. This is called our magnetic field and the magnetic field lines. So let's move ahead. Now we can imagine by this it is that like that. So when we put here also, so it can imagine it by this. So this is the particular imaginary magnetic field. By this all the magnetic lines are arranged in the closed forms, and all are arranged in closed forms. It is our imaginary magnetic field and their magnetic lines. So are you understanding this? It is the important point. I hope you will be understand the magnetic field. So what is this? These are the types of magnet. And what is magnet? The materials that attract iron or iron like metals like nickel, cobalt, iron. These are the three and etc. material metals that are be attracted by the magnet. So all metals didn't attracted by magnet. Only metals like iron, cobalt, nickel are attracted by magnet. So it is horseshoe magnet, bar magnet that we see in that. It is the magnet needle used in compass. So it is the horseshoe magnet, yes, it is the simple magnet, cylinder magnet, etc. Loop magnet are these are the types of magnet. So let's move ahead. So what are the basics of magnet and magnetism? Magnet, yes, we know materials that attract ion or ion-like materials is known as magnet. So let's see ahead. So this is our imaginary lens. So we know that a magnet has two poles, south poles and north pole. So it look like this means it all move from north to south, north to south, north to south, north to south in a outside of magnet. So what it is? So let's see. So first of all we need to learn basics. So they are mainly of two types of natural magnets and artificial magnets. Means two types of natural and artificial magnets have more power and it has two poles, north and south, and that can never be separate. Means north and south is never can be separated by magnet. So it has like poles repel, whereas unlike attract. Means north south attract and south south or north north like poles repel. You know that easily. So let's move ahead. So how can we find the direction of that magnetic field? Means by these magnetic lines we can find direction if we put around the magnet many compasses. Like with this there are many compasses, and the red needle means the red side of needle in compass directs the north side. Means the north side is directed here and all sides are directed here. So by this we can say that north side, wherever the red needle poses it, it is the north side. So it's not that the north to south, it's not direction. The direction is where the red needle means where the magnet starts its direction, that is north side. I hope you are understanding it. Means for example, the example of sun. We know that sun rises from east. That north means wherever the sun rises, it is known as the east direction. It's like that wherever the magnet starts its direction, it is the north direction, north side. I hope you are understanding it. So by this, wherever we put the magnets, put the magnetic compasses, we can understand it. So let's move ahead. We can already see. So by this, all the magnetic poles start from north to south outside the magnet, but in inside the magnet the direction is south to north. Hope I will understand. South to north. Inside the magnet the direction is south to north, but outside the magnet the magnetic field lines all are north to south. Direction are north to south. So what is this? This is also an example of magnet north and south. So tangent. What is the tangent? Tangent is also an the measuring of direction. Means tangent at any point of magnetic field lines give the direction of magnetic force. Like this. Means here we can say if it is a line, we want to we want to find the direction of this circle. So we need to draw a tangent here. So direction of tangent, it is the direction of that magnetic field line. So if we draw here tangent, so direction of tangent, it is the direction of that magnetic field line. So by tangent we can also give the direction of magnetic force. So these are the properties of magnetic field. There are total 6 properties. Means 6 properties. Closed curves means they are like closed curves. Close. Hope you will keep it in mind. All are in closed curves. They didn't in straight line. They all are like curved close. You already seen like this. Yes, they are all are in closed curves. Closed curve. It is also closed curve. So this is then one of the property. So let's start by first. Concentrated are places of strong magnetic field and spread apart at places of weak magnetic field. Oh, this is also an important point. Let's see this diagram. So in this diagram, what we can understand, in the middle there is weak force because the weak are attracted, but in the edges of the poles, at the poles, the crowded, it is very crowded, means all the ion fillings are attracted in the edges, in the poles of magnet, but in middle it is weak and in edges it is strong. By this we can consider it. So third point is outside the magnet field lines go from north to south. Means outside to magnet field lines goes direction is north to south and inside it south to north. We already discussed it. So field lines never intersect. Means we can say it is a field line. It is a field line. They don't intersect like this. They don't intersect like this. They are always curved. They are always closed curves. These are the 5 or 6 important properties of magnetic field lines. Let's move ahead. So what we have to discuss in this chapter, we have to discuss the Fleming's right hand rule, left hand rule, electric motor, Hans Oersted. Yes, this is an important Hans Oersted. Hans Oersted is the scientist of magnetic effect of electric current. He introduces the magnetic effect of electric current in the world. So he is the Hans Oersted, HO, the short form of Hans Oersted scientist. So we already discussed about magnetic field. We already discussed. So magnetic field, due to it is formed by the lines. It is formed by the lines. So we can say magnetic field lines. Yes. So direction we already discussed. So what is this? Attraction and repulsion between magnets. If we join two magnets attracting, so if you joint a magnet towards its north and towards its south, it looks like it. When we imagine it, their magnetic field lines look like it. But when the repulsion is happen, means if you join both like charges north north or south south, it looks like it, magnetic field. You can easily observe it is look like it. So let's move ahead. So the chapters, important chapters, what are the magnetic field, field lines we already discussed. Magnetic field through a current carrying straight we are already having to, we'll discuss in this part. So these are the points we completed. First point, let's start to other point. This is also the point, DC motor, parts of working, electromagnetic induction, etc. So this is what? This is the magnetic field through electric current carrying straight conductor. So this is a conductor. Let's suppose this is the conductor and this is the glass rod. So by this experiment, what we can observe that electric current also forms a magnetic effect. Means how form it? Let's see. So this is a glass tube and we put here all the iron fillings around it, around the conductor. This is a wire. Around the conductor we put all the iron fillings. So by this, what happen after some time, when the conductor on, means when the circuit is flow through that wire conductor, that in the glass the iron fillings are looking like this. Means they are looking like a magnetic field. Yes, they are looking like they are performing a concentric circles. What is concentric circles? Means all the circles having one point. So by the electric wire, by the conductor, by the electric current, that also form the magnetic field. Also they form magnetism. So by the electric current in a glass, on the glass tube, the all iron fillings are getting in a concentric circles. Yes. So look like this. Here we can say like, but here in imagine a current wire. And the magnetic field lines look like this. Yes. So what are this? This is an wire. Means how to conductor current carrying conductor, means this is directly proportional or inversely proportional, what we have to discuss. So if we can simulate a electric wire and its magnetic field and it is an object, so what happens if we increase it? If we increase the current of carrying conductor, the magnetic field also increase. Means current is directly proportional to what? Magnetic field. Means current. If we increase the current of conductor, the magnetic field also increase, like this. We increase current, increase the magnetic field. So again we increase it high, they increase the magnetic field. So by this we can understand current is directly proportional to magnetic field. So let's move ahead. So if we the direction is upwards, 1 minute. If the direction is upwards, it's anti-clockwise. Are you understanding it? If the direction of current is upwards, the direction of magnetic lines also anti-clockwise. If we change the direction of current, downwards, the magnetic field lines direction also changes. Means if upward, it is anti-clockwise, and if the current is downward, it is clockwise. I hope you are understanding it. So how can we find the direction of field lines? Means it is also an form, but if we didn't know the side, so there is also another example by how can we find the direction of field lines. So let's see. By the right hand thumb rule. You can write right hand thumb rule. This is a rule by which we can find the electric current and its direction. So what is its rule? So the rule says magnetic field above wire right, means if the current is upwards, so can we find this hand? Yes. By this we can send, means the thumb is like this. Yes. Like this. By this we can say that the current moving this side. But if a current is downward, the current moving this side. Means by thumb rule. I can't explain this properly, but you want to discuss it, so subscribe my channel, and there is some videos and you can see on Google also. Means if current is upward, it looks like this, and current is downward, it looks like this. This is the simple thing by right hand thumb rule. So the three properties have we discussed. Magnetic field around a straight current carrying conductor is in form of concentric circles. Means concentric circles, yes. Direction of magnetic field can be found by right hand thumb rule. Imagine a straight conductor in your hand. If the thumb points direction of current, then curled fingers give the direction. Means if thumb is created to the wire, the remaining four fingers of the right hand give the direction of that magnetic field. So this is also an example. So I hope you discussed it. So for this video, for the part 1 of magnetic effect is over. So in this आज के लिए इतना ही बस. So if you like it and if you understand my example, understand my all the chapter explanation of the part 1 magnetic effect of electric current, so like and subscribe to my channel, please. लाइक कर देना भाई. सो गुड बाय.